Welcome to Slothful Slumber, the podcast where we transform the vast knowledge of the internet into a gentle lullaby for your mind. I'm your host, Luna Dreamwell, and I'm here to guide you on a journey to tranquility through the soothing cadence of Wikipedia articles. Each episode will delve into the most wonderfully mundane and sleep-inducing topics, helping you drift off into a realm of serene dreams. So find your comfortable space, close your eyes, and let the dull hum of information carry you into a restful slumber. Now, let's embark on tonight's voyage of tranquil learning as we explore a topic so peacefully uneventful, it just might whisk you away to the land of dreams. This Wikipedia article is titled Quartz. Quartz is a hard crystalline mineral composed of silica, silicon dioxide. The atoms are linked in a continuous framework of silicon-oxygen tetrahedra, with each oxygen being shared between two tetrahedra, giving an overall chemical formula of silicon oxide. Quartz is, therefore, classified structurally as a framework silicate mineral and compositionally as an oxide mineral. Quartz is the second most abundant mineral in Earth's continental crust, behind feldspar. Quartz exists in two forms, the normal alpha quartz and the high-temperature beta quartz, both of which are chiral. The transformation from alpha quartz to beta quartz takes place abruptly at 573 degrees Celsius, 846 Kelvin, 1063 degrees Fahrenheit. Since the transformation is accompanied by a significant change in volume, it can easily induce microfracturing of ceramics or rocks passing through this temperature threshold. There are many different varieties of quartz, several of which are classified as gemstones. Since antiquity, varieties of quartz have been the most commonly used minerals in the making of jewelry and hard stone carvings, especially in Europe and Asia. Quartz is the mineral defining the value of 7 on the Mohs scale of hardness, a qualitative scratch method for determining the hardness of a material to abrasion. Etymology. The word quartz is derived from the German word Quarz, which had the same form in the first half of the 14th century in Middle High German and in East Central German, and which came from the Polish dialect term kwarty, which corresponds to the Czech term tvrd, hard. Some sources, however, attribute the word's origin to the Saxon word Querklufterz, meaning cross-vein ore. The ancient Greeks referred to quartz as kristallos, derived from the ancient Greek kruos, meaning icy cold, because some philosophers, including Theophrastus, understood the mineral to be a form of supercooled ice. Today, the term rock crystal is sometimes used as an alternative name for transparent, coarsely crystalline quartz. Early studies, Roman naturalist Pliny the Elder believed quartz to be water ice, permanently frozen after great lengths of time. He supported this idea by saying that quartz is found near glaciers in the Alps, but not on volcanic mountains, and that large quartz crystals were fashioned into spheres to cool the hands. This idea persisted until at least the 17th century. He also knew of the ability of quartz to split light into a spectrum. In the 17th century, Nicola Steno's study of quartz paved the way for modern crystallography. He discovered that regardless of a quartz crystal's size or shape, its long prism faces always joined at a perfect 60-degree angle. Crystal habit and structure. Quartz belongs to the trigonal crystal system at room temperature and to the hexagonal crystal system above 573 degrees Celsius, 846 Kelvin, 1063 degrees Fahrenheit. The ideal crystal shape is a six-sided prism, terminating with six-sided pyramid-like rhombohedrons at each end. In nature, quartz crystals are often twinned, with twin right-handed and left-handed quartz crystals. Distorted, or so intergrown with adjacent crystals of quartz or other minerals as to only show part of this shape, or to lack obvious crystal faces altogether and appear massive. Well-formed crystals typically form as a druse, a layer of crystals lining a void, of which quartz geodes are particularly fine examples. The crystals are attached at one end to the enclosing rock, and only one termination pyramid is present. However, doubly terminated crystals do occur where they develop freely without attachment, for instance, within gypsum. Alpha quartz crystallizes in the trigonal crystal system, space group P 3121 or P 3221, space group 152 or 154 resp. Depending on the chirality. Above 573 degrees Celsius, 846 Kelvin, 1063 degrees Fahrenheit. Alpha quartz in P 3121 becomes the more symmetric hexagonal P 6422, space group 181, and alpha quartz in P 3221 goes to space group P 6222. These space groups are truly chiral. They each belong to the 11 enantiomorphous pairs. Both alpha quartz and beta quartz are examples of chiral crystal structures composed of achiral building blocks. The transformation between alpha and beta quartz only involves a comparatively minor rotation of the tetrahedra with respect to one another without a change in the way they are linked. However, there is a significant change in volume during this transition, and this can result in significant microfracturing in ceramics and in rocks of the Earth's crust. Varieties, according to microstructure. Although many of the varietal names historically arose from the color of the mineral, current scientific naming schemes refer primarily to the microstructure of the mineral. Color is a secondary identifier for the cryptocrystalline minerals, although it is a primary identifier for the macrocrystalline varieties. Varieties, according to color. Pure quartz, traditionally called rock crystal or clear quartz, is colorless and transparent or translucent, and has often been used for hardstone carvings, such as the Lothair crystal. Common colored varieties include citrine, rose quartz, amethyst, smoky quartz, milky quartz, and others. These color differentiations arise from the presence of impurities which change the molecular orbitals, causing some electronic transitions to take place in the visible spectrum, causing colors. The most important distinction between types of quartz is that of macrocrystalline, individual crystals visible to the unaided eye, and the microcrystalline or cryptocrystalline varieties, aggregates of crystals visible only under high magnification. The cryptocrystalline varieties are either translucent or mostly opaque, while the transparent varieties tend to be macrocrystalline. Chalcedony is a cryptocrystalline form of silica consisting of fine intergrowths of both quartz and its monoclinic polymorph mogonite. Other opaque gemstone varieties of quartz, or mixed rocks including quartz, often including contrasting bands or patterns of color, are agate, carnelian or sard, onyx, heliotrope, and jasper. Amethyst. Amethyst is a form of quartz that ranges from a bright, vivid violet to a dark or dull lavender shade. The world's largest deposits of amethysts can be found in Brazil, Mexico, Uruguay, Russia, France, Namibia, and Morocco. Sometimes amethyst and citrine are found growing in the same crystal. It is then referred to as ametrine. Amethyst derives its color from traces of iron in its structure. Blue quartz. Blue quartz contains inclusions of fibrous magnesio-riebeckite or crucidolite. Dumortierite quartz. Inclusions of the mineral dumortierite within quartz pieces often result in silky appearing splotches with a blue hue. Shades of purple or gray sometimes also are present. Dumortierite quartz, sometimes called blue quartz, will sometimes feature contrasting light and dark color zones across the material. Blue quartz is a minor gemstone. Citrine. Citrine is a variety of quartz whose color ranges from pale yellow to brown due to a submicroscopic distribution of colloidal ferric hydroxide impurities. Natural citrines are rare. Most commercial citrines are heat-treated amethysts or smoky quartzes. However, a heat-treated amethyst will have small lines in the crystal, as opposed to a natural citrine's cloudy or smoky appearance. It is nearly impossible to differentiate between cut citrine and yellow topaz visually, but they differ in hardness. Brazil is the leading producer of citrine, with much of its production coming from the state of Rio Grande do Sul. The name is derived from the Latin word citrina, which means yellow, and is also the origin of the word citron. Sometimes citrine and amethyst can be found together in the same crystal, which is then referred to as ametrine. Citrine has been referred to as the merchant stone or money stone due to a superstition that it would bring prosperity. Citrine was first appreciated as a golden yellow gemstone in Greece between 300 and 150 BC during the Hellenistic Age. Yellow quartz was used prior to that to decorate jewelry and tools, but it was not highly sought after. Milky quartz. Milk quartz or milky quartz is the most common variety of crystalline quartz. The white color is caused by minute fluid inclusions of gas, liquid, or both, trapped during crystal formation, making it of little value for optical and quality gemstone applications. Rose quartz. Rose quartz is a type of quartz that exhibits a pale pink to rose-red hue. The color is usually considered as due to trace amounts of titanium, iron, or manganese in the material. Some rose quartz contains microscopic rudal needles that produce asterism in transmitted light. Recent X-ray diffraction studies suggest that the color is due to thin microscopic fibers of possibly dumortierite within the quartz. Additionally, there is a rare type of pink quartz, also frequently called crystalline rose quartz, with color that is thought to be caused by trace amounts of phosphate or aluminium. The color in crystals is apparently photosensitive and subject to fading. The first crystals were found in a pegmatite found near Rumford, Maine, U.S., and in Minas Gerais, Brazil. The crystals found are more transparent and euhedral due to the impurities of phosphate and aluminium that formed crystalline rose quartz, unlike the iron and microscopic dumortierite fibers that formed rose quartz. Smoky quartz. Smoky quartz is a gray, translucent version of quartz. It ranges in clarity from almost complete transparency to a brownish-gray crystal that is almost opaque. Some can also be black. The translucency results from natural irradiation, acting on minute traces of aluminum in the crystal structure. Praise. Pras is a green variety of quartz. The green color is caused by inclusions of amphibole. Prasiolite. Prasiolite, also known as vermarine, is a variety of quartz that is green in color. The green is caused by iron ions. It is a rare mineral in nature and is typically found with amethyst. Most prasiolite is not natural. It has been artificially produced by heating of amethyst. Since 1950, almost all natural prasiolite has come from a small Brazilian mine, but it is also seen in Lower Silesia in Poland. Naturally occurring prasiolite is also found in the Thunder Bay area of Canada. Piezoelectricity. Quartz crystals have piezoelectric properties. They develop an electric potential upon the application of mechanical stress. Quartz's piezoelectric properties were discovered by Jacques and Pierre Curie in 1880. Occurrence. Quartz is a defining constituent of granite and other felsic igneous rocks. It is very common in sedimentary rocks, such as sandstone and shale. It is a common constituent of schist, gneiss, quartzite, and other metamorphic rocks. Quartz has the lowest potential for weathering in the Goldich dissolution series, and consequently, it is very common as a residual mineral in stream sediments and residual soils. Generally, a high presence of quartz suggests a mature rock, since it indicates the rock has been heavily reworked, and quartz was the primary mineral that endured heavy weathering. While the majority of quartz crystallizes from molten magma, quartz also chemically precipitates from hot hydrothermal veins as gangue, sometimes with ore minerals like gold, silver, and copper. Large crystals of quartz are found in magmatic pegmatites. Well-formed crystals may reach several meters in length and weigh hundreds of kilograms. The largest documented single crystal of quartz was found near Itapor, Goiás, Brazil. It measured approximately 6.1 meters by 1.5 meters by 1.5 meters and weighed 39,916 kilograms. Mining. Quartz is extracted from open pit mines. Miners occasionally use explosives to expose deep pockets of quartz. More frequently, bulldozers and backhoes are used to remove soil and clay and expose quartz veins, which are then worked using hand tools. Care must be taken to avoid sudden temperature changes that may damage the crystals. Related silica minerals. Tridymite and cristobalite are high-temperature polymorphs of silicon oxide that occur in high silica volcanic rocks. Coesite is a denser polymorph of silicon oxide found in some meteorite impact sites and in metamorphic rocks formed at pressures greater than those typical of the Earth's crust. Stishovite is a yet denser and higher pressure polymorph of silicon oxide found in some meteorite impact sites. Moganite is a monoclinic polymorph. Le Chatelierite is an amorphous silica glass, silicon oxide, which is formed by lightning strikes in quartz sand. Safety. As quartz is a form of silica, it is a possible cause for concern in various workplaces. Cutting, grinding, chipping, sanding, drilling, and polishing natural and manufactured stone products can release hazardous levels of very small, crystalline silica dust particles into the air that workers breathe. Crystalline silica of respirable size is a recognized human carcinogen and may lead to other diseases of the lungs, such as silicosis and pulmonary fibrosis. Synthetic and artificial treatments. Not all varieties of quartz are naturally occurring. Some clear quartz crystals can be treated using heat or gamma irradiation to induce color where it would not otherwise have occurred naturally. Susceptibility to such treatments depends on the location from which the quartz was mined. Prasiolite, an olive-colored material, is produced by heat treatment. Natural prasiolite has also been observed in Lower Silesia in Poland. Although citrine occurs naturally, the majority is the result of heat-treating amethyst or smoky quartz. Carnelian has been heat-treated to deepen its color since prehistoric times. Because natural quartz is often twinned, synthetic quartz is produced for use in industry. Large, flawless, single crystals are synthesized in an autoclave via the hydrothermal process. Like other crystals, quartz may be coated with metal vapors to give it an attractive sheen. Uses. Quartz is the most common material identified as the mystical substance Maban in Australian Aboriginal mythology. It is found regularly in passage tomb cemeteries in Europe in a burial context, such as Newgrange or Carramore in Ireland. Quartz was also used in prehistoric Ireland, as well as many other countries, for stone tools. Both vein quartz and rock crystal were knapped as part of the lithic technology of the prehistoric peoples. While jade has been since earliest times the most prized semi-precious stone for carving in East Asia and pre-Columbian America, in Europe and the Middle East, the different varieties of quartz were the most commonly used for the various types of jewelry and hardstone carving, including engraved gems and cameo gems, rock crystal vases, and extravagant vessels. The tradition continued to produce objects that were very highly valued until the mid-19th century, when it largely fell from fashion, except in jewelry. Cameo technique exploits the bands of color in onyx and other varieties. Efforts to synthesize quartz began in the mid-19th century as scientists attempted to create minerals under laboratory conditions that mimicked the conditions in which the minerals formed in nature. German geologist Carl Emil von Schaffhautel, 1803 to 1890, was the first person to synthesize quartz when in 1845 he created microscopic quartz crystals in a pressure cooker. However, the quality and size of the crystals that were produced by these early efforts were poor. Elemental impurity incorporation strongly influences the ability to process and utilize quartz. Naturally occurring quartz crystals of extremely high purity, necessary for the crucibles and other equipment used for growing silicon wafers in the semiconductor industry, are expensive and rare. These high-purity quartz are defined as containing less than 50 ppm of impurity elements. A major mining location for high-purity quartz is the Spruce Pine Gem Mine in Spruce Pine, North Carolina, United States. Quartz may also be found in Caldovero Peak in Asturias, Spain. By the 1930s, the electronics industry had become dependent on quartz crystals. The only source of suitable crystals was Brazil. However, World War II disrupted the supplies from Brazil, so nations attempted to synthesize quartz on a commercial scale. German mineralogist Richard Nacken, 1884 to 1971, achieved some success during the 1930s and 1940s. After the war, many laboratories attempted to grow large quartz crystals. In the United States, the U.S. Army Signal Corps contracted with Bell Laboratories and with the Brush Development Company of Cleveland, Ohio, to synthesize crystals following Nacken's lead. Prior to World War II, Brush Development produced piezoelectric crystals for record players. By 1948, Brush Development had grown crystals that were 1.5 inches, 3.8 centimeters, in diameter, the largest at that time. By the 1950s, hydrothermal synthesis techniques were producing synthetic quartz crystals on an industrial scale. And today, virtually all the quartz crystal used in the modern electronics industry is synthetic. An early use of the piezoelectricity of quartz crystals was in phonograph pickups. One of the most common piezoelectric uses of quartz today is as a crystal oscillator. The quartz oscillator or resonator was first developed by Walter Guyton Cady in 1921. George Washington Pierce designed and patented quartz crystal oscillators in 1923. The quartz clock is a familiar device using the mineral. Warren Marrison created the first quartz oscillator clock based on the work of Cady and Pierce in 1927. The resonant frequency of a quartz crystal oscillator is changed by mechanically loading it, and this principle is used for very accurate measurements of very small mass changes in the quartz crystal microbalance and in thin film thickness monitors. Almost all the industrial demand for quartz crystal, used primarily in electronics, is met with synthetic quartz produced by the hydrothermal process. However, synthetic crystals are less prized for use as gemstones. The popularity of crystal healing has increased the demand for natural quartz crystals, which are now often mined in developing countries using primitive mining methods, sometimes involving child labor.